So, hey, hello, Remy, how you doing? You're right. So today we're discussing VLANs. So basic technology, really old technology, really old concept, but a really important one, especially with our CCNA studies. So where do we start? Who wants to go first? Who wants to start describing VLANs for us? Your understanding of VLANs, what VLANs accomplish, and stuff like that.
As far as I understand, VLANs are like layer two uh, LAN segments,
Yep.
or
Yeah, good one, very good one. Layer 2 LAN segment. Anything else in terms of what VLANs are?
I'll describe it as the by the name
Yeah,
is the virtual local area network.
yeah, okay.
Simple. It's logical. It's really not physical, but it's just a way to have logical segments
Yeah,
on the physical line or something like that.
yeah, good one. Any other thoughts on these VLANs? What's your thought on what VLANs are um, and what they mean to you? Like if you were to go to an interview and they ask you describe VLANs, what would you say? Remy, you want to go for that? Let's say something. Because I know you're like the college guy. So so I'm sure you have lots to say about this.
Simple. It's like of a way of using layer two as a subnet. That's what I will say.
Yeah, the subnet, yeah, good one. I mean, we're getting really good definition and stuff. Carlos, Imran, anything else?
Uh, VLANs actually are they are LAN segment. We create them to just manage, you know, in manageable and in good manageable way, so we can filter the traffic and everything, limit the broadcast,
Yeah,
and
what happens to podcasts?
because it's separate between the VLANs.
Yep, good one. Um,
And also, it for security, we don't let the traffic, normal user traffic, go to management or something like that.
okay, yeah, good one. Okay. I mean, this is a really, really good point. Does anyone have anything else to add? I mean, this is a really, really good point. Layer 2 LAN segment, virtual local area network, using layer 2 as a subnet, broadcast domain. Because it is absolutely right. In the sense that when networking first started, the limitation um, used to be a collision domain, which we discussed like many weeks ago. A collision domain, and a collision domain simply means everything is sharing a single bus. Really? So everyone is sharing a single bus. So you have a single, sort of like a single cable that everyone is sharing. So every computer on the network is connecting to this cable and they're sharing this cable. So this is like the limitation because there's so much device that you can connect before you start having problems. So you can connect a device here, connect another device, connect another device. The moment you start getting larger and larger, you start having problems. So the limitation is the collision domain because everybody is sharing a single physical bus. So if this guy sends something at the same time this guy is sending something, there'll be a collision, which is okay for a small network. But then if you have 50 devices, then the probability of having a collision is greater. So then they came out with like switches, which um, when we mentioned before, switches separated the collision domain. So every single device that you're connecting is running on its own separate bus. So when you connect your computer here, your computer is running on its own separate bus. It's not sharing the bus with other devices connecting to this. Whereas inside the hub, everyone is sharing a single bus. So this one means we can have more devices connected on this network. But then the limitation became the broadcast domain because if a broadcast goes out, it has to go to everybody connected to this switch. So if another broadcast goes out from a computer, it goes out to everybody in this switch. And does anyone know the recommended number of devices on a broadcast domain? Or what would you say?
Approximately 50.
50? Okay. Any other answers? So before you start thinking, okay, we need to start separating this broadcast domain to a separate network. Like how many devices do you think?
Well, I will go with my experience with Microsoft.
Yeah.
Usually, Microsoft prefers you to stay under 10.
On the 10, I mean for a
Yeah.
broadcast domain,
Oh,
not
for a broadcast
yeah,
domain.
no, yeah, not for collision domain, yeah.
Well, even for a broadcast domain,
Mm,
it's still really on the don't go beyond what usually advocate is
mm,
make your broadcast domain as small as possible.
mm,
So usually if it's on the user side, you
mm,
understand, you can what do you call it, access switches. They will advise you make them segments of 10. But otherwise, you can go, I think, as high as maybe 250 something.
mhm,
But then that's what it's not. As I said, this is with experience.
yeah,
Is because one thing is to say that this is what they advertise, but another thing is to actually use it on the field, and then you start having trouble.
yep,
You can't meet what they actually advertise there.
yeah,
So
okay. I mean, any other thoughts? Like, what do you think, Powell and Imran and Mark? What do you think? Like, how many devices do you reckon that, I mean, that you say to, I mean, if you're working in a company, how many devices do you say, okay, we've got this many devices on this network segment. I think it's time that we break it into a separate segment. Like, how many devices will you go for?
I already said 50.
50, yeah, Iman said 50. Sorry, Iman. I thought that was Carlos. For some reason. Carlos, what do you think?
I really have no idea.
Yeah. Okay, let's
yeah,
say
not sure.
Power says if you make it as small as possible, you have to use layer 3 device each time when you send something. I think it really depends on network, but I will not put more than 50, the same as Imran. Yeah, yeah, but I think that, but I think Cisco's recommendation, I think is 250. They said when you start getting to 250, you start having problems with too many broadcasts on your network because you have 250 devices and they're sending broadcasts, they want to communicate with this device, they're sending broadcasts. I think Cisco's recommendation is about 250. You start getting, when you get to about 250 devices on the network segment, then you start having problems of too many broadcasts. Yeah, exactly. Yeah, so it's not always. I mean, I know, for example, like currently where I currently work, I mean, we even have like segments that are even larger than 250, I think. We've not had that much of too much issues with that because devices like in modern day networks are like really really fast in terms of like their processing and the switch backplane and the ports themselves are like gigabit ports and all that stuff. Um, but that's just my own thought on this. But I think Cisco mentions that when you get about 250, that's when you start seeing problems with too many broadcasts um, sorry, too many broadcasts on your network that's starting to affect network traffic. Then we have any other thought about regarding this?
So Cisco says 250, but really it comes down to the network design, what type of hosts are on the network, and how often they may be communicating.
Yeah, yeah. That's right. Also, my way. Yeah, and that's right, Mark. In terms of like, so maybe if you have devices that will always be that that maybe the broadcast. I think it all like it all depends because if you've got it all depends on your network. Because what you don't want is a situation where broadcast is taking away majority of your bandwidth. So you always want to monitor your network to find out is there too much broadcast going on and stuff like that.
Your host as well.
Yeah, yeah. And
Like if
then
your hosts are designed to be like time clocks or specific function, they may not communicate
yeah,
the same manner
yeah. And
all
then
the
the other
time.
thing is that there's a feature on switches, on newer switches where you can limit broadcast traffic on a port. So you can say this port can only send 255 broadcasts in a second or something like that. So there's a feature like that in modern switches where you can say, okay, I'm limiting the amount of broadcasts that can come out of this port in a second, something like that. Okay, yeah. So then this one used to be the limitation of the network, where we have like the switches. So then what will now happen is people will have a switch which will represent your LAN segment, and this one is connected to a switch, and then you have um, your router in between to separate them. So this switch is connected to this one. So this one is your broadcast domain here. This switch here is your broadcast domain. This switch is another broadcast domain. And then they are all communicating with a router in between. So if you need another LAN segment, you will need another switch. And then you have another switch again. And then you create a broadcast segment from that, another broadcast segment from this. And then you have to connect them to the router in order for them to communicate. But does anyone know what the problem is in this type of scenario? What's the problem in this type of scenario?
Overusage of that router.
Well, depends on number of ports you have. You may run out. Most routers don't actually have that many ports, so you may run out of ports. You may run out of. You have a lot of. You have to buy hardware, a lot of switches.
Yeah.
So suddenly you have footprint problems in case you're like in a data center. You want to make things as small, use as little space as possible, or maybe an enterprise where you want to house more people to work than the equipment. So your space is limited, your locker room space is limited. The more switches you use, the more space it takes, the more power it drains. Everything just escalates from there.
Yeah. Yeah, good one. Very good point, Mara. If you look at what Imran and Powell mentioned in the chat window, said Imran said router on a stick. Powell mentioned it's usually layer 3 switch, which by the way is faster than router, so it's not a problem. So actually, let's say like normally, like we're talking about like the evolution. So this one will be a normal router, but the problem with this will be if this guy wants to communicate with a device that is on this segment. So let's say this is segment A and this is segment B. And a device in segment A wants to communicate with a device in segment B. Its traffic will go all the way to the router and then gets transferred back out this way, get transferred back to this guy. But the limitation is the connection between the switch and the router. But that's not only the only limitation is that the router is way much slower, like Powell said, than the layer 3 switch. So that becomes like a problem because this router is processing things in software, which is way much slower than the way the switches process stuff. So that became like your limitation. So even though now you've separated like all your broadcast segments, now you're still having a problem in terms of bottleneck because this one can slow things down. So then came like VLANs where we can separate things to different segments just based on layer 2 alone. We can separate things on different segments, and then we'll have a layer 3 switch to connect them together. Okay, so let's move a step further. So in terms of like reasons to use VLANs. So what are your reasons to use a VLAN in a network?
For fast switching?
For switching? Did you say for switching, Imran?
I mean routing, sorry, routing, because if you put layer 3 switch, it's a hardware base. He do switching, so internally it's fast than router. So if you use it, it's fast routing as well.
Okay, yep, routing. Any other reason why you use? I mean, you mentioned one earlier. You mentioned
we separate the VLANs because we want to use or put more security in it. we want to filter the broadcast, not to go to other VLANs, limit the broadcast. And then we want to make VLANs like we don't want to put user data on the management, or so it's also, I think, filtering.
Yeah, security. Yeah. Any other reason apart from security why you want to use VLANs?
Or design options, flexible design.
You manage it. It's for management. It's easy to manage. Okay, this is management VLAN. This is user VLAN, or this is for this department. This is for this department, and maybe it's also useful when we do route summarization or something like that.
Okay. Yeah. Mark, you were saying something also.
Oh, I think you got it. My microphone was up. I didn't realize it. Let's see. What did he say? Easy management. Design for flexible design. You can like segment departments and things like that for security, and I guess it's under I don't know.
Segment department, yeah. So that'll probably be like easy management.
Flexible, like yeah, you could break up the network, into smaller segments.
Yeah. Any other reasons to use VLAN?
I would like to say cost efficient too. Instead of buying a bunch of routers.
Good, very good. I mean, that's a really good one. That'll get you a promotion,
I wish.
Cost, cost efficient. So instead of buying a router to segment or different switches to get segment, good one, yeah. So any other reason why you want to use VLANs?
Because you told us to.
No, no, no. I'm not even sure if I want to use VLAN.
I mean, I can only think of specific examples where you might have like voice over IP traffic or different type of traffic that you want to segment.
Absolutely, that's a really, really good point, Carlos. Really, really good point. Things like QoS. Because one thing you can do is once you separate your network and you break them down into this network and this network, then what you can do is say traffic in this VLAN have a higher priority. So you can use VLANs to configure quality of service, which prioritizes traffic on your network. So that's a really good one. So that's one of the reasons why you separate your voice network from the data network. Why? Because once you separate it to a different VLAN, then you can give priority to traffic in that VLAN. So, which is a really, really good point. QoS. Any other reason? I mean, good reasons. I mean, we're getting really, really good reasons here. So, any other reason? Why? Any other reasons that we want to use VLANs on our network? Any other reason?
Oh, I just heard my name. Sorry, I was trying to set up my packet tracer to mimic the connection. What was the question again?
Yeah, so we're talking about the reasons for using VLANs. So we've mentioned, I mean, guys have mentioned like really, really wonderful ones, like okay, for
Routing,
routing, for
security,
security,
management.
just to break up the network into smaller segments, and then we got
Yeah,
for
that's
cost
broadcast
efficiency.
domain, cost
Yeah,
efficiency,
then we got for
QoS.
QoS.
Any other reason?
How about like troubleshooting? Ease of troubleshooting.
Yeah,
Like,
that makes it. That's why breaking up also qualifies as that.
okay.
It makes it easier to troubleshoot.
Mm.
What else? What other reasons would you do VLANs? Um, uh,
Any other reason
hmm,
that would say, okay, this is a good reason why we should separate these guys into like separate VLANs and stuff.
mm,
If I think about it properly, I'm trying to think of some myself to like.
Yeah,
Really
I most of what I can think of, I'll find it either like two of these reasons define it, or maybe one of them already defines it.
Mm-hmm.
Yeah, because it's really for making it easy to do layer three,
Mm-hmm.
for specialty applications.
Mm-hmm.
So either you want to have security, or you want to run separate, like QoS,
Yeah.
run separate applications on it, or stuff like that. Make it easy to manage. Yeah. To me, this is basically most of it.
Mm-hmm.
I can't really think of any other reason right now
Yeah.
for
Me,
VLAN.
me, yeah. Me too. I can't really think of any other reason.
I
But
mean, I don't know if it's already stated in others, but like kind of controlling a flow by having it logically broken down. You're not sending data you don't need to all the ports or
Yeah,
yeah, so
that
that would be this one, filter broadcast.
that will
yeah.
filter broadcast and QoS. So that's what I was saying. Anything else to say, I'll find it.
We
I'm more
can
likely finding it within maybe one or two or three of the things mentioned.
Yeah.
we can use also STP with VLANs to redundancy for
Okay,
making
okay,
one
yeah.
VLAN as a priority.
Okay, I see what you mean. Like in terms of like
Making
part.
one priority, one secondary, and one primary.
Yeah, yeah,
We also can say that okay, user from VLAN 1 doesn't access from the VLAN or the data from the
yeah. So that'll be under
network
security.
from the financial stuff,
Yeah. So you can
access
use it to,
control,
yeah. You can use
access
it to
control.
configure
Yeah.
access list. So that will be under security. So I think we've got everything covered basically. So in terms of routing, I mean, we've got all the answers in between all of us. So for security reasons, for easy management, one, baby, baby, sorry, want to break up the network to smaller segments. You want to, for cost efficiency. So instead of you buying multiple switches, you can just create VLANs, and then because also if you think about like the cost efficiency, also like um, easy management. One of the things that you can put into easy management is this: is somebody comes to you and says, "Hey, we need a new network." And the new network, we want it to be secret and separate and everything like that. So it will take a lot of weeks, probably, depending on how you order your stuff in your company, for you to say, let's order a new switch, and then maybe we need to buy a new router card to be able to plug it into. That will take longer time for you to go through the process of ordering a new switch and doing all that. Whereas you can create a VLAN just within a few minutes and you're done. And you have a separate network that no one can access. Maybe the research team in your company comes and says, we need a new network. Rather than you having to order new equipment, you can just create a new network right there with your existing equipment. So that's like part of like ease of management in terms of flexibility and stuff like that. And then we got QoS, really, really good reasons. Okay, so normally or typically in network, we'll usually have our switches. We usually have our switches here. So the question is this: if you want to create a VLAN, you go VLAN 20 from the configuration mode. You go VLAN 20. Your VLAN configuration information, where is it stored on this switch? So that's the question. So your VLAN configuration.
It's VLAN dot under running config.
That's a good one. Okay, let's put that down. It says under running config. Who agrees with that? Running config. Imran says it's saved under running config.
I'm not sure it's saved on the running config.
Okay.
I
It's
think it's saved. I think it's saved in one. If you configure it, it may stay under running config. But when you save it, it's saved on the. I've forgotten what memory it is that you can't wipe
It's
it.
startup config. Then
No,
if you
no, no,
save it, then it's in startup config.
oh, no, no. I'm talking about when you save VLAN information. Actually, because this happened to me once. I took a switch. I didn't check it. I just assumed it was um had no VLAN, had nothing inside it. Plugged it into a network. It had no configuration. It had no running config in there. Plugged it into a small network, as a lab network, and suddenly I found out that the thing was taking over the whole thing, like took over my whole VTP, virtual trunking stuff, just took over the whole thing, renamed the domain, gave some VLANs that I didn't even define, added it to the network, and I was like, what's going on? Later on, I found out that when you configure VLANs, it's stored in a special memory, but you can't wipe it out. You can edit it, but you can't wipe it. So one has to be careful when you're moving switches across from one place to the other, because you can't really remove that VLAN configuration. I just forgot what memory is stored in.
Okay, let's make it easier. Let's do this. What are the different memories that we have on a switch? We have our flash, right? We have our NVRAM, right? Which other memory do we have on a switch?
We have the ROM, or is it?
Yep, good one, ROM. Which other
We have
memory do we have? Any other memory? Yeah, so let's say we have these memories, we have these three memories on. So do we have a separate RAM apart from NVRAM on a switch? That's one of the reasons why I like about like Hangout is that it's a good thing to get to discuss many things, and then many things come out that we're like, oh, we have to answer this question to be able to go ahead. So which other memories do we have on a switch? So do we have a separate RAM different from the NVRAM, or is the NVRAM the RAM? Which one? Carlos, what do you think? So what are the memories that we have on a switch?
I would think you would have a separate RAM.
Yeah,
Separate.
of course, you can put RAM that where are the running config. It's not in the ROM, not NVRAM, and not in flash. So it's
So
in
you're
RAM
saying we have a
because
separate
it's
RAM.
Yeah.
Okay. So any other thoughts? Does anyone agree that the NVRAM is the same one as the RAM, or they are different, the RAM and the NVRAM?
NVRAM and RAM are different because when you shut down your switch, everything in RAM just gone. And if you did not save it in, I would suppose, in heavy RAM, which is non-volatile,
Mm-mm.
then you lost everything.
Okay. Yep. Okay. Sounds good. Yeah. Any other thoughts? So everyone agrees that there's a separate RAM apart from NVRAM.
Of course, everybody agrees.
I'm not. We have to. You know what, Imran? I'll tell you something. Like it's not. It's to one of the reasons why we're doing the whole discussion is that many things come out that it's good because of this way we can help one another to understand
Of
stuff.
course, of course.
Because maybe there's someone that maybe is like a bit confusing, that maybe someone has not even thought about it, that oh, NVRAM and RAM, are they the same or are they different, and stuff like that, because it's one of the reasons why we're bringing up this. So we go flash. Okay, so what is stored in the flash?
iOS.
iOS, yeah, good one. What else?
Startup config. You can
Start.
store that in the flash.
So let's go startup config in the flash. Is that right? Was
No,
that
I
I
say you can
think it's
store
in
you can.
NVRAM, no?
It's in every RAM, but you can store any file you want. What I was trying to say is you can store any file you want in the
okay? Yeah,
flash.
in the yeah, I get what you wow. Yeah,
Now
so
that's
we
why I
can
said
start.
startup
Yeah,
config to get
so
everyone. You can store anything you want.
any file. Yeah. Okay. What about NVRAM? What is stored in our NVRAM?
Backup and startup configuration.
Yep. Startup configuration. What else is stored in our NVRAM? What about our ROM? What is stored in our ROM? It says everything will
It's
save.
like
Yep. You're
a
right, Femi.
small iOS to run, copy from flash to ROM to run in the beginning in the booter.
What did you say, Imran? I didn't get that quite
I
well.
said in ROM is a small iOS that copies from flash.
Small iOS.
Means
Ah,
necessary to run to make it fast booter, you know. And of course, I think post also the hardware check.
yep. Power says we have the boot P and we have post. What about our RAM? What is stored in the RAM?
Running config.
Running config. Good one. You know what? You know what? You know, just this little thing that we did. You may not. Good. Yeah, Ramon. Sorry, we forgot Ramon here. What is Ramon used for?
Config the registers.
Yeah, good one. And it can be used to recover passwords. Right?
Yes, actually I did quite a few times because I forgot and I have to do it because my teacher said, you put the password, now you have to recover it.
Yeah. Yeah, when device failed to boot also. Yeah. Okay. So you may be surprised that this has actually, just going through this has actually helped someone. You may be surprised. Maybe it reminds us of something we've read in the past or something like that, but this is actually like something helpful. Okay, so the next question that we were asking is, says, do we use BIOS on a switch? Does anyone want to answer that question? Do we use BIOS on a switch? Carlos, what do you think? Do we use BIOS
No,
on a switch?
not as I'm aware of.
Yeah. So it's not so it's not exactly it's not BIOS exactly, but it functions like the BIOS, but it's not. Yeah, exactly. So it's not BIOS
Yeah,
exactly,
something
but
like Roman.
yeah.
Yeah.
So it's not the BIOS exactly. Okay, so the question that we're asking is this: is that where is your so out of all these memories that we got, where in the world is our VLAN information stored?
Yeah, I think it's NVRAM.
Okay.
Um,
So
well, it's in multiple places, right? Well, no,
Just consider
it's
you
not on
didn't
this.
do the copy run start.
okay, let's do it this way to to make it simple. If you think it's flash, say yes. VLAN configuration information is stored in flash. Do you agree or disagree? Who agrees? So
I
silence
think
means
it's in multiple
disagree.
places.
Okay, Powell agrees. I also agree.
I say flash.
Oh, Mark agrees. So we got Mark, Powell, David. Who else
I
agrees
think it's
that?
at least in Flash.
So Carlos, are you saying flash?
From my understanding, the information would be in more than one place, but Flash would be one of them.
Yeah. Okay, so you're saying flash, right?
But you are using Flash as a storage, then you are copying just everything there, you know. You're transferring file, you put the config, you know, file, and then you copy it on a Flash. But actually, when you are running it,
Hmm?
from where it's actually taking, I mean, from where iOS taking that information.
Yeah.
That question should be like that. Okay, we can put like Flash is a storage, we can put anything, you know, but from where the iOS
Okay.
taking the VLAN information.
My question is, where is the VLAN.dat file stored? Where do you see it?
Exactly. So that's the
Because
question.
that's where
Because
the
Ah,
power.
actually,
yeah, Flash.
yeah,
That's Flash.
because it's not, you don't even have to save it there. You see, one of the reasons why Imran, can you see one of the reasons why we're having discussions like this? Because sometimes, sometimes I tell you, like, one of the other reasons is because aspects like this of things like flash and things like memory like this, if you've not worked with the equipment in the real world, you're less familiar with this. You're more familiar with, with the concepts and stuff like that, but you've not worked with the equipment over and over and over again. You're less familiar with it. And then we have a forum where we have people that have worked with the equipment and people who are learning the technology and everyone in different places of learning coming together so we can discuss all these things and help one another understand it better. Remy wants to say something.
Uh, I would like to go the way things work in the computer, and I would say that chances are it's gonna be like that on the Switch.
Mm,
Let's say you have the everything when the computer come from the manufacturer and you're using it, and even though when you have it at home, everything is saved on the ROM, the read-only memory.
mm-hmm,
From there, you have the BIOS, which is you guys already say the ROM on. So once you start your computer,
mm,
that ROM on or the BIOS is moved to the flash memory, and it does all this thing, and it moves everything, call the OS, and put it in on the random access memory, which is the ROM. And there, if you need to do any other thing, configurations, and that will be saved on the NVRAM, which is the non-volatile memory, which save your own stuff.
Yeah.
Is it confusing?
No, it's
Confuse
not.
anybody?
It's not. It's really not. If you look at it, what you're saying is really not. But I think the confusion actually is in the use really of it. Because I'll give you this. Like I said, from my own personal experience, I thought that, okay, it's the flash, right? VLAN data is in the flash. I deleted it, right? I plugged in the switch and it messed up the lab network. I'm like, okay, so where else is this configured? So one thing I do know is that I don't remember where exactly, but I do know that on the clients, on like when you're doing VTP trunking, we're not doing VTP trunking right now, VLAN trunking protocol. But when you're doing VTP trunking, the VLAN information is stored, or maybe I should say VTP information. Maybe that's why I'm mixing up. If you guys can correct me. On the client, you store it somewhere different. On the server, you store it somewhere different. When you save, it's stored in Flash. Things like that. So one has to be careful as what you're doing where that VLAN information is stored.
Yep.
So
Do you
that's
agree
why
with
it can be confusing.
do you agree with that we have to delete first the VLAN.dat and then we have to delete the startup file to clear all the VLAN info?
Actually, like I agree with what Powell said. VLAN information is stored in the flash, but then when you load the computer, of course, the iOS is loaded into RAM, and then the VLAN.dat file is also loaded into RAM. So it's stored in the flash and loaded into RAM. And I just found this documentation, which I'll post in the chat window for us to go through. Where let's go. It says Cisco Catalyst switches that run iOS releases maintain the VLAN information in a special file named VLAN.dat. And then it went ahead to describe the way this works. VLAN or VTP configuration changes are written to NVRAM immediately after a change is made. In contrast, that is in CatOS. In contrast, Cisco iOS software does not save configuration changes to NVRAM unless you use the copy run stats command. VTP client and server requires update. It says during boot up, the switch compares the content in the VLAN.dat file and the configuration in startup config to determine if it should use the configuration in VLAN.dat or startup config. When you save VTP mode, domain name, VLAN configuration in the switch startup configuration file and reboot the switch, the VTP and VLAN configuration are selected by this condition. If both the VLAN database and the configuration file show the VTP mode as transparent, okay, yeah, this one we actually talk about this one also, like when we talk about VTP data. Well, from that, it's the configuration. I mean, just from my own understanding, it's stored in VLAN.dat, which is saved in the flash, and then it's loaded into the RAM when the machine boots up.
All right, so I think that's what messed me up because I didn't switch off the switch.
Yeah.
I just deleted the VLAN file, VLAN.dat file, saying, "Oh, VLAN
Exactly, but it's already loaded
just
it into the RAM.
I just plugged it in.
Yeah.
It was still in NVRAM, and it just messed up my lab, and I was like, "Oh my God, what did I do wrong?"
Yeah.
Yeah, so that makes more sense.
Yeah.
So ultimately, the flash is like the master long-term storage.
Yeah. So the VLAN configuration file that when you're typing your VLAN configuration, the file is saved in the flash, but then loaded. So if you do show flash here, you can see the VLAN file. So you see, once any change is done to the VLAN database, the switch automatically creates the VLAN.dat file. So it creates that inside the flash. I mean, that's from my own understanding again. And so it's something that we need to verify again properly. But from my own understanding, I agree with what Powell said, in that VLAN information is saved on the flash and then loaded into the RAM when it's booting up. So I'm not sure. Does anyone else have any other thought about it?
What you're saying makes perfect sense because I know from my own knowledge to VLAN information should be stored in the flash in the VLAN.dat file.
Yeah.
But every switch is in is it in the default mode for VTP of every switch is server,
Yeah.
so it loads automatically into the MV RAM,
Yeah.
and so once you make a configuration change,
Mhm.
it loads into MV RAM, and then you're stuck with it. You have to actually like shut it down, delete it, save that, then shut it down, then restart it to make sure your MV RAM does not have the VLAN information
Yeah.
of the old information, and your VLAN dat file is empty. So that's how you can prepare the switch for that. So you're right.
Yeah. Yeah. It's
Yeah.
kind of like also like when if you transfer a new iOS to your
hmm
flash,
Yes.
it won't actually load until you do the reboot
Exactly, until you
into the
reboot.
RAM. So the one is loaded into the RAM that it's running with, it's what it will carry on running with.
hmm
Then when you reboot, it'll be like, okay, yeah, I'll load this new updated iOS that you've put into the flash, stuff like that. Okay, so let's move a bit further here. So now we know, yeah, yes, Imran. So we've discussed and mentioned that the location where the VLAN information is stored. VLAN information is stored in a database called VLAN.dat, and the VLAN.dat file is saved in the flash and then loaded into RAM when you boot. Yeah. So then the next question is that, because this one will be relevant for the exams. I mean, I know they're really simple for some of us, but then there's some of us that are just learning this stuff. So there are two methods of creating VLANs on a Cisco switch. There are two methods. So what are those two methods? What are those two methods for creating VLANs on a Cisco switch?
Putting the command in the configuration mode, like VLAN 10, VLAN 2, 20, something. And the other is we can use VTP.
Okay, yeah. So what's the second method?
Oh, VTP.
VTP, no, that's not the second method for creating VLANs. Two methods for creating VLANs.
Okay. Are you talking about when we go and say access VLAN like 10, but it's not in the created, but after that it will create. Are you talking about that?
Yeah, the one that we do from the privileged mode.
Switch port mode
So let's bring up packet tracer. So if I bring up
or
packet tracer and let's just go,
switch port access. That's what it is.
I don't know the command, but I assume there's a way to edit the database.
yeah, exactly, yeah, that's right. If I go client, so now it's fake loading not sure why it's loading, but it's pretending as if it's loading something. So the first mode is the one that Imran mentioned. So you go under your configuration mode and then you just type in the VLAN that you want to create, VLAN 20, VLAN whatever you want to create, and you press enter. Now, if you show VLAN now, you can see VLAN 20 has been created. The other way is on the privileged mode, which is this mode. I can go, what's the, how do we get into that? Is it VLAN? Yeah, okay, let's go VLAN database. So you can go VLAN database and press enter. And then it comes up with this warning saying, it is recommended to configure VLAN from config mode as VLAN database mode is being deprecated. So please consult. So basically, this is the older way of creating VLANs. The config mode is the newer way. So this mode it will be going away in new switches.
Yeah, I think that's why Ira mentioned the VTP stuff.
Yeah.
You can do that. Yeah.
Yeah. Okay. Yeah. Okay. I get. Sorry, Imran. I didn't quickly catch that.
And also we can create that without putting the command. It's create automatically when we assign a interface to a VLAN that is not created.
Yep.
And when we assign that, it creates automatically, and then you can verify it
Yep.
in the database.
Yeah. So that's also. So let's actually put that down. So that's right, Imran. So let's put that down. So that's another way. So let's say three. Let's take three away. So one way is in the config mode. One way is just go and assign a port to a non-existing VLAN. And what that means is this: if I go to packet tracer and I go um, and go under an interface and go to assign it to a VLAN that doesn't exist. Switch ports, more switch ports. Well, let's go switch port. Access VLAN 30. Enter. So it says VLAN does not exist, but I'll create it. So you just assign a port to a VLAN that doesn't exist, but it's going to create it automatically. So now if we go to show our VLAN, there will be a new VLAN called VLAN 30 that it just created it because you assigned it. Yeah, but that's so just remember that there are two ways. The VLAN database in privilege mode, which is like the um, old way. Does anyone know one of the main differences between creating VLANs this way and between creating it on the config mode? There are two major differences between the two modes. What do you think?
No, I think in NetAcad course CCNA we didn't learn to create VLAN in
With this
like in
one, yeah, because it's going away, yeah. I mean the two major differences I mean is, for example, if I go to exit this one and I go conf t and I go VLAN 40, the moment I press enter, it creates that VLAN. But if I go to the VLAN database mode and press VLAN 50, it's not created it. It's like, yeah, I'm adding it. And I go VLAN 60, it's not created anything. It will only create it after you exit or apply. So if you go exit, then it's going to apply all the changes and create it immediately. Whereas if you go to the config mode and just press VLAN this one and press enter, it creates it. So this one is more of like a session based. This is like a session. You enter all the commands in the session. When you exit the session, it will apply all the commands. Whereas in the other mode, the moment you enter the command, it just creates it instantly. But this one is like session. So when I now go exit, you will see it says apply completed. So it's now applied it. And actually, if this is like a view switch, I can abort it without applying it. There's another command called abort. But because this is packet tracer, there's no command there. So I can go abort and type in VLAN 30, VLAN 40, VLAN 50, and I'm like, oh, I don't want to create this, and just go abort, and we'll abort the session and won't create those VLANs. The other difference is that this one can only create VLANs for you. If I go Q, VLAN database, this can only create VLANs for you within a particular range. VLAN, it can only create VLANs for you between 1 to 1005. Does anyone know how many VLANs or what's the maximum VLAN number?
this is this is a range of the standard VLANs.
Yeah, exactly. Standard VLANs. Whereas normally we can create up to, which number can we go up to?
Is it 4094?
4096
Yeah.
something.
No, it's 94, right? Mark is right.
Yeah.
So it's 4094. So this one will only allow you to create the standard range of VLANs, which is 1 to 1005. Whereas, you can go. Is it 4096 or 4094?
I thought I read 94, but I have no.
I think it's 94. Yeah,
Why?
there's
Yeah, I was
two.
thinking it's 94. See.
I've read 94, but I don't know why.
What's this VLAN? ISL VLAN ID is what?
Well, your switch may limit you number of VLANs it can handle too. The hardware limitation.
But I was thinking, but there's a 29. Let's see.
Or I guess it depends on the
Your
iOS.
packet tracer, if you do version for your packet tracer, you find out is 12.2, so it's actually old software.
Let me switch
Yeah.
off my ISR. Maybe I can see there.
Yeah, that's strange. That's the first time I'm noticing that it's not even allowing me to create up to 494 up to this one. Okay, yeah. So those are the three major ways of creating VLANs like on a Cisco switch. Um, 4096 depends on iOS. Okay, So do VTP status, Powell said. Sorry, you mean do show VTP status, sorry. Show VTP status. Maximum VLAN supported locally 255. I'm not sure. Does anyone know what this one means? Does this mean that even if the switch allows you to create up to 1000 VLANs, you can only create 255? Is that what this means? Maiwa, what do you think? Is that what this one means? Maximum VLAN supported locally. Hello?
Honestly, I don't have a clue what that means. I think someone should just Google it. I
Yeah.
don't.
So yeah,
I'm leaning towards the fact that yes, maybe that's what you can support for that switch.
okay. Because the
Yeah,
other
in terms
question
of
I will
memory.
have, the other question I will have is, does this mean you can only support this one if you're using VTP? So maybe if you're not using VTP, you can create the full range that you can create. If you're using VTP, it only supports 255.
Well, that also means that maybe you can only have 255, but you can use any range of numbers to up
You
to
want.
1,000. So you can have 255, but one of them can be 2,000. I mean 1,000.
Yeah. Yeah, so you can use the full, but yeah, but what I now mean is that does this one apply only when we're using VTP, or does this apply whether we're using VTP or not? Like maximum VLAN supported locally. So that means maybe if I'm not using VTP, it means that I can create as much as I want as far as the switch supports it. Or if I'm using VTP, it only supports 255.
Yeah, I think it's limited to VTP because depending on the switch, some switches actually tell you 1005
Mm-hmm.
instead of 255. I've seen that with 1005. Yeah, a different number.
Yeah.
So it might be different. Does anybody have GNS3 running to try it out? Let's see, because that's more of the iOS than Packet Tracer, which is a simulation.
Actually, Mark posted something on the. Let's see.
Not sure it has a table on there, VLAN ranges.
Yeah.
Yeah, that's okay. Yeah, it says extended, but these are like for extended VLANs and stuff like that. It says maximum VLAN supported on a Cisco switch. Maybe it's worth googling it. I know this is something that we should do in advanced studies, maybe in a CCNP studies or so. Maximum VLAN supported Cisco switch. Okay, I think someone asking the same question here. Let's see.
Yeah, Pavel actually mentioned that the iOS limits your VLANs.
Yeah, it supports everything because it does. Yeah. Okay, good point, Power. Maximum show VTP status. Okay, so someone mentioned refer to this
Yeah,
document.
I'm gonna just fire up my GNS3 and just do that run that command and see what I'll get.
Someone is saying this is the maximum number of per VLAN spanning tree instances supported by the switch. I think this is something that we'll just need to do more research on. Yeah, let's do more research on it. I'll probably mention my findings in the next Hangout. But yeah, this is something interesting that I want to find out the maximum number. Maximum anything. Okay, yeah, actually, look at this. It says the switch supports per VLAN spanning tree with a maximum of 128 spanning tree instances. One spanning tree instance is allowed per VLAN. Yeah, but that is like for spanning tree. Anything else? Maximum MTU. Yeah.
Does it matter what type of like is the packet tracer ISL versus 102?
Yeah, that
802.1 Q
that's
is
what
that make a difference?
yeah that's what Pavel was saying, and I think I agree with him because the packet tracer is simulating 12.2, which is old. I've seen 12.4 with more than 255. So I'm sure there are others. The 15 versions will have more than that. So I think it's determined by your iOS. But what we're trying to say now is we're not sure if that number is limited to VTP because the VTP command, or if it's limited to the total number of VLANs you can actually have running on the switch.
Yeah. Okay. Okay. Yeah. So I think we'll move on from there. We'll have to do a bit more research and then come back to discuss that one. Okay. But then three methods for creating VLANs in the config mode, in the privilege mode, which is being deprecated, and then in the just assign a port to a non-existing VLAN, and it automatically creates that. Okay. So let's move a step further and let's move over to trunking now, which is a fun subject, trunking. So we'll do the same model. So what's your understanding of trunking? Should we start with Carlos first?
Trunking is not just an access port. It's typically used between switches.
Yep. So typically used between switches.
I guess back. Yeah.
And what's it used for between switches?
Connection.
Good one, Mark. Trunking is used for connection between switches.
Really, you're allowing all the VLANs to communicate over it usually, or more than one.
More than one VLAN. Okay. So any other thoughts on trunking? So what exactly, when you say you've got a trunk link, what are you talking about? Think about an interview, like you've been asked a question, say what's your understanding of trunking?
Trunking is protocol, because it's a trunking protocol, VTP trunking protocol. It's a means whereby you can send frames with VLAN tags across a physical link. So it's almost a way whereby you can combine multiple VLANs on one physical link and can send it across. So the frames that are not the VLAN that is native to that particular link would not need to have its frame tagged, but every other VLAN that is sending frames out will have their own frame. It's still going to send through the same logical link, same signal, but just that you have a VLAN tag on the frame to segregate it. That way, the other switch at the other side knows where to send those frames to. You can identify that, okay, this frame is for VLAN 90, this frame is unmarked, so it's my native VLAN, so it's VLAN 1, for the example, or VLAN 20, stuff like that.
I think of it as a trunk of a tree, or all the branches, all the connections coming back to one, where
exactly
you have simultaneous connections.
That's exactly how it looks like. That's a great apples to apples comparison. Have multiple branches all coming to the same tree using that same major trunk branch. So not branch, trunk. So have multiple branches, which are your VLANs, all coming together, bound together. But you have to be able to separate them.
Okay, good one.
Consistency.
Any other thoughts on that, Mark? You mentioned something now. Any other thoughts on what's your own understanding of trunking? Or what's your understanding of what a trunk is? Or why you need a trunk?
Are you talking to me?
Yeah.
Oh, okay.
Because you mentioned something now.
Oh, I was just reading something. Yeah, the way to connect switches, but to share VLAN information.
Okay, good one.
So the switches know about the other, if you're sending from one VLAN to the same VLAN on another switch, it knows, where the destination is. I guess.
Okay, yeah. And
Something
Kerry,
like
what's your thought on trunking? What trunking is, or why
Uh,
would, yeah, why do we need trunking?
it's it's a way in which you can communicate via switches.
Yeah.
They tag each, well, except for the native VLAN when they're communicating, it's tagged with the ID,
Mm-hmm.
the VLAN ID, and yeah, that's what I have so far.
Okay. And any other thoughts on that?
For me, trunking is a link between access is switches or access switches that carries traffic from different VLANs. And how they do that, they put in the headers, they put the tag which this frame belongs to which VLAN, and because it's one link, so that's why we configure it as a trunk, so it carries different kind of VLANs in it,
Mhm.
and I think that's all.
Yeah. So everything you said is absolutely correct. But just to help break it down for people that are just getting involved in this is normally in an infrastructure you will have your or what you call your access switches that your computers connect to. And then you probably have your distribution or core switches, which will go off to the internet somewhere. So you have a link between your switches that your computer are connecting to and the computer. So you have your port here. And what happens is that if you connect your computer to this, as far as the computer is concerned, the computer is like, yeah, I have no idea um, of anything called VLANs or anything like that. You go to your switch and you say, okay, this switch, this port 1, I'm configuring you for VLAN 2. Say this port, I'm configuring you for VLAN 1. This port, I'm configuring you for VLAN 4. So the computer doesn't know anything called VLAN, it just knows I'm receiving traffic and that's all about it. But then what happens if, let's say, there's a server that's connecting to this guy, and this server is also on the VLAN 2 that you've created. So this guy needs to be able to receive information from this device on VLAN 2 here. So you have a connection between this switch or your access switches and maybe your distribution or your core switches. Usually, these ports are usually faster than this port. So maybe this one will be 1 gigabit port. This one will probably be 10 gigabit ports because that way you can carry, you can accommodate multiple communications at the same time. So this one will probably be, you know, if you see your typical Cisco switch, let's bring up like just a typical Cisco switch. A Cisco switch. And then if you go on the images, you notice that there are two separate port banks here. So you see like the normal ports, this ones, this probably not better one there. Let's pick this one. So you can see the normal port here, and then on the right hand side you can see these two ports. So maybe these other ports will be 1 gigabit links, and then these two ports on the side they will be called uplinks. This one will probably be 10 gigabit, which means they are 10 times faster than these normal ports. So this one will link this switch to maybe the distribution switch at the top, while this one will connect to your computers and other stuff like that. So what happens is that this port that's connecting up to this other switch here, um, you may have another device here. Maybe you have another server here, and this server is on VLAN 4. You've configured this port. You said this port is on VLAN 4. Now, communication between this device and this device will go through this link. Communication between this device and this device will go through this link also. So that means there must be a way to separate this traffic across this link. Yeah, good one. Nice one, Powell. So Powell is explaining the uplink ports and the way they work. So that means there must be a way to separate those two traffic for VLAN 2 and traffic for VLAN 4. There must be a way to separate them, but they are going across a single link. So that's where trunking comes in. And like all of us have mentioned, trunking is a way to tag frames, not packets, frames. It's a way to tag frames with the VLAN that they belong to. So, in other words, what that means is this. This guy sent information and he's like, I want everyone on VLAN 2 to receive this information. He sent a frame, not a packet. So, layer 2 frame, sends a frame. This frame has to travel on this link. There must be a way for us to identify and say, on this frame, you're going to VLAN 2. So that when this guy also sends its own packet and says, yeah, I'm going on this same link, there must be a way for us to identify it and say you're going to VLAN 4. So that when they go across this link, this tag will go on them. They get passed to the other side. When this guy receives it, this guy is like, I can see you're going to VLAN 2. So I will only send you outside this port. There's no point me sending you outside this port because this port doesn't belong to that VLAN. And in the same way, this frame also can go on the same link. And when this guy receives it, it's like, I see you're going to VLAN 4. So I only send you outside this port. So the technology of doing that, of marking frame, of putting a mark on frames, so that we know which VLAN they belong to, the technology is called trunking, or as some people put it, tagging. So that's like the whole point of trunking. So like we all said, it's a way of connecting switches together, and then we'll get into like the details a bit more. So the other thing I want to say is that a trunk link, is it only between two switches? Is there any other thing that you use a trunk link for?
Router and a switch.
Sorry, Kevin, I didn't get that.
Router and a switch.
Router and a switch, good one. So let's put that down. So we use a trunk link between number one, two switches. Number two, router and a switch. So any other thing? Yeah, so Power mentioned something, switch and a router. Sorry, switch and a server. So in which situation, so does anyone want to expand more on this, switch and a server? In which situation will you want to configure a trunk between a switch and a server?
When do you want to limit what traffic the server is going to receive?
Not really, like, so like trunking is like you can carry the frame for multiple VLANs, right?
Some servers have special software that I think you can actually do it on Microsoft too.
Mhm.
You have special software whereby you can actually have where the NIC can actually recognize different VLAN tags or handle VLAN tags. You also have some servers that actually have multiple NICs,
Yeah.
so they may be connected to different ports on the same switch. You know, so which we can use to separate them out. That okay, this is this VLAN, that's that VLAN. So, but if you're going to have to use trunking for a server, it means that the particular NIC on that server recognizes, or the software can actually handle tag frames. That's basically, yeah.
Yeah.
Or is it possible to like a dedicated DHCP server handing over the IP address to the different VLANs? That
I didn't get the question, Imran. Yeah, virtual
I,
server. Yeah, exactly. So that's like a very good example of when you need to configure a trunk between a switch and a server because of virtualization these days. Because you have virtualization, a virtual server is a server that you have multiple servers between it. So you have one server here, and they're all virtual servers, which we all use today, you know, with all kinds of VMware, ESX, Hyper-V. You have virtual servers inside this server. So you have virtual servers inside this server. But let's say this server could belong to VLAN 4. Why this one belongs to VLAN 2? Oh, sorry, VLAN 3. Why this one belongs to VLAN 2? So the connection, so this server here has NIC ports on the NICs here. So actually, when you're configuring it, this NIC, you won't see it as a normal, no problems, Mark. You won't see this NIC as a normal NIC. It's not like a normal NIC. It's actually functioning similarly to like a switch. So you have this one go connecting here. So this is kind of like a switch because this one, like Maiwa mentioned, it has an application inside it that can recognize tags. So that way, this link has to carry frames for VLAN 4, frames for VLAN 3, frames for VLAN 2, just within this same link that goes up to a server. So that's like one situation when you need to configure a trunk between a switch and a server. So then the other question will be, we said trunking is a way to tag frames with the VLANs that they belong to. So there are two major methods for doing this. One of them again is going away, but there are two major methods of tagging frames. Two frame tagging methods. So does anyone know what those two methods are?
.1q and ISL.
Good one, 802.1q and ISL. So what's the difference between the two of them?
Can I stop for a moment
Yes,
because
please.
I asked a question and then actually it went away.
I didn't get
I
the
said,
question, sorry.
yeah,
Yeah.
the question was that we have a dedicated server,
Yep.
DHCP server on the other side of the router,
Mm-hmm.
you know, and then we have this situation where you have access switches and then you have, you know, the VLANs information and
Yep.
then host connected to the. And when they ask for DSP request for the IP address, this is also be one of the switch and the server relationship, right? Could be. Is it the same where you will put it?
No, so that will be something different. Yeah, exactly, the one that Power mentioned. So that will be IP helper. So what you're saying is you have
Yeah,
yeah.
I know what is IP helper. I means that will be also the link between them will be like a link between that will be a link of trunk or it will be
No,
a it
just
will
normal
be a
access. It will be a normal access port, and I'll tell you the reason why. It's because when it gets to the router
yeah.
sends it out to the computer, to the server. So this is a unicast packet between the router and the computer. And the router is only asking the computer, and the router is only saying, give me an IP address for this subnet. So it's not a multi-VLAN communication. It's a unicast communication between the router and that server.
Okay, perfect.
So
Yeah.
I
So
think but let's get something clear. I think
yeah.
what part of what Imran might be saying is that if you have multiple clients, if you have an access switch
Mm-hmm.
and you have multiple clients in different VLANs,
Yeah.
and you have a DHCP server maybe connected to another switch, this is a core switch, right?
Yeah.
Which is connected to a router. Now the router is going to use the IP helper
Mm-hmm.
to sort out because depending on what port it receives it,
Mm-hmm. Yeah.
that has a particular VLAN assigned to a particular VLAN
Yeah.
on the access switch.
Yeah.
You may need to still have trunking in between the router and the switch so that the router, because you're going to most likely going to use maybe one link,
If
right?
I understand Imran's question very well, I think Imran's question is talking about between the switch and the server, right?
Between the switch and the server.
No. I said like you have a link.
Yeah.
You are connected. Okay, it's switch is connected to router, and the other end of the router is also connected to a switch, and
So
the switch is connected
let's take, so we have
to
a
the
switch
D.
here. So this is a switch, and
Yeah,
the switch is connected to a router.
Mm-hmm.
yeah.
Yeah. And then
Other side is connected to the multiple access switches.
So this one is also connected to another access switch.
Yeah.
Yeah, okay.
And here you put different VLANs and host are connected. When host gonna ask for request DHCP request,
Wait, let's
okay,
connect. Wait, hold on. Let's connect to the server too.
So
DHCP server.
three. So you have, let's say, two. So then you have a DHCP server connected here, right?
That's okay.
Okay. So you have a DHCP server connected here, and let's say
And
DHCP server is
wait,
on VLAN 4, right?
yeah, but let's make sure the DHCP server can actually give DHCP addresses for different VLANs.
Yep, you can. Yeah, so you can give DHCP address for VLAN 4, for
4,
VLAN
5,
3, for VLAN
3,
2. Yep.
2. Yeah. In that case, between the server and that access port, it's going to likely you need a trunk.
No, we don't. Between the
Why?
server and the switch,
Yeah.
it's going to be an access port.
Why will it be an access port? Because
Because
how will it
it's
send
not
out
carrying
information?
any VLAN information. See, the traffic will come from this router here.
Uh-huh.
And this traffic coming from this router here, it's going, this one will be a trunk. This one is not like a tagged multi-VLAN communication. This one is going directly to this server. So the packet will look like source IP is from this router here, router IP.
No, wait. What I'm saying is this. I'm saying what I'm talking about is, so when a broadcast frame, okay, let's say a GCP requests a broadcast frame is a broadcast. Yeah, it's a broadcast.
It's a unicast. No, it's a unicast to that server. So the router is sending a packet directly to this server, not a broadcast. So once.
Okay, and it will have the information about the router that sent it.
Yeah. So exactly.
Okay.
So the way it's gonna. So let's say. So that's like another. So let's say this one. So let's say the device here. It's on VLAN. So this one is on VLAN 4, right? Let's say this one is on VLAN 3. This one
Actually, my idea was here to put where you put row 3. I wanted to make a DHCP server here.
And so let's make this one a DHCP client. So this one is a client. So this is the server here. So Imran, is that right? Is that okay? So this one.
No. I wanted to where you put it. No, not this one. Where you wrote only the 3. You just wrote the 3 now.
Yeah. So if we make this one a DHCP server.
DHCP server, yeah.
Yeah, server.
Okay. Of course, we will create at the LAN side of the router. We will put IP DHCP IP helper address. But the link between the router and the DHCP server.
No, the router is not connecting to the DHCP server. The router is connecting.
Sorry, switch. I mean,
yeah,
switch.
Definitely, the link always, 100% of the time, the link between your router and your switch, if you want it to route multiple VLANs, will always be a trunk. But the one between
what was my
switch,
question from the beginning, actually.
Yeah, which is what I was answering. That I actually typed it there. That no matter what you're doing, what you should always think about in terms of trunking is that if you're going to have to send between two devices tag frames, you need trunking.
Exactly. So that's the only time that you need trunking. But again, remember, in this case, this is not like a tagged frame or something like that. It's going to be tagged in between the router and the switch. So when this router is sending that packet, it's going to say, I'm sending it to VLAN 3.
All right. So I don't want to digress us too much, but I'm saying, let's say, and that's because I've not really looked at the packet. Let's say we have like this VLAN 3 and we have VLAN 4. So VLAN 4 sends a request saying I need an IP address, a DHCP request, broadcast, send it to the router. The router uses the IP helper to send a unicast packet, not packet, unicast pretty much.
It's gonna be packet also, yeah.
Well, unicast packet, because he's sending it to the server. Now the server would now send back so it's going to send it that way and send it straight to the server using the same. Oh, because the server is still on the same IP address. So I get what you're saying now. So the server now sends back the packet with
this one will
information.
still be an access port. It's not that one at all. Because again, the information is not like it's a tag. The information about which IP address you're getting, it's embedded inside the DHCP section of the packet. Yeah, exactly.
And that's actually IP3. That's
exactly.
3, not layer 2.
Yeah.
So you don't need that.
So there's no need for trunking in between the server and this one and the switch. So between the server and the switch is going to be an access port for whatever VLAN that is going to be, whatever VLAN that you want to put your DHCP server. The one that will be the trunk is between the switch and the router, but between the server and this one will be an access port. Does that answer the question, Iman?
Well, I think that's where the subnetting come from when we're using a VLAN, because each VLAN in the different subnet
Yeah. But then
usually.
again, remember that this router also has IP addresses on all the different subnets.
Hmm.
So exactly. So this one is going to be like I've got IP address in, I've got uh maybe let's just say it's a layer 3 one. Let's say it's got interface VLAN for one is 192.168.1.1. Then it's going to be like interface VLAN 2 is 192.168 and dot 2.1. So it's got all these interfaces that it's going to receive. So you go on this one and you say IP helper 192.168.1.1. The router is just basically gonna go, okay, I've received this packet. This is not layer 2, this is layer 3. I've received this packet um, on this one. So I'm going to say source IP address is this one, and I'm sending it to this destination IP of this one. And it's just going to do routing in between the two. That's all. I'm not sure if that is clear, but yeah. But this one is definitely an access port. It's not
Yeah.
a trunk port.
Yeah. So what you mentioned actually is clear. And I'm sorry, guys, I asked that question. I just want to make it clear.
Yeah, no.
What we're trying to sort out there was that DHCP protocol
Yeah.
is actually I think layer 3, layer 4, or application layer sort of protocol is not layer 2.
Yeah.
The only reason why you need to tag your frames is layer 2.
Yeah.
So anytime you are dealing with anything higher than layer 2, you usually do not need to tag your frames,
Yeah.
because you're not looking at that
Yeah. It's not
particular
dealing
frame
on
there.
layer 3 at all. Sorry,
Yeah,
on layer 2 at all.
and layer 2 at all.
Yeah.
The only time what that will happen is if you need to, and I don't see why, if you need to have separate DHCP servers on for each VLAN, which maybe
Even with
for in
that,
terms of capacity.
yeah, even with that, it's gonna be, even if you have like separate ones, the port will still be an access port if
The
you're using
access, yeah, it'll
IP
still be access
helper.
port.
Yeah.
Yeah, it'll still be access port.
So Imran, I mean, it's something that we can lab. Actually, I'm not sure. I think I have a YouTube video on this on IP helper. I'm not sure, but I think it's something that we'll still get to also later. But I hope that answers the basic question for now.
No, I know IP helper and all this concept,
Mm.
and I can build that. But I was just when somebody raised a question
Yeah.
between server and router, so that's why I was thinking, is it
Is
can
that
I
one of the
count
situation? Yeah. Okay.
DHCP server as a server
Yeah.
related to if I put directly DSP server
Mhm.
to the router?
Yeah.
Is it possible?
So this is not one of those situations that you use
Normally,
something like that.
yeah.
Yeah. So I mean, to me, the only situation where I've seen between the router and we have guys in the research department of my company where they have these powerful desktop machines that run multiple computers on them that are on different networks. So they have this one that is on the research network, they have this one that is on the lab network, they have this one. So everything is within a single computer that they are running. So their ports, we usually make them trunk ports because then inside their machine they will now say, okay, this traffic is for VLAN 2. This one is for VLAN 4. This one is for VLAN 5. Or for virtual servers like the ASX host or Hyper-V host in our company. So the link between that one, because actually inside your Hyper-V host is a layer 2 switch.
Yep,
So
that's what I was
yeah,
saying, that Microsoft
yeah.
does that.
So
That's
that's
why I
the
said
only
Microsoft
reason
does
because
that.
yeah, exactly. So between the DHCP server and so there's no layer 2 switch inside the DHCP server that's understanding tags. So the only thing the only those are the only two situations I've seen that you configure a trunk between a server and a computer. Okay, let's move a step ahead. So we mentioned that there are two ways of tagging. You said ISL and 802.1q. So what's the difference between the two? Let's quickly. So what's the difference? ISL 802.1q. What's the difference?
ISL, I think that's Cisco only,
Yep,
and
Cisco proprietary.
that queue is IEEE
Yep,
standard.
IEEE. Yep, IEEE standard. Any other differences between them?
The dot Q is more popular because it can be used with all devices.
Yep, sure. Open standard. Yep, so more popular. Any other main differences? There's another big difference between the two of them. I know Powell knows. Remy, there's a big difference between ISL and 802.1q in terms of the way they do the marking, the way they do the tagging.
I was just about to say the way they do the tagging, but
Yeah,
I can't remember exactly what it is, but I know it's the
can
tagging.
someone help Kerry with that? The way ISL does its tagging and the way 802.1q does its tagging. Anyone? Remy, come on. You can do it.
No clue, no clue, no clue. I have no clue.
Well, is there just
Mark.
more bytes in the frame?
Oh, yeah, okay. Yeah.
Just,
Carlos said something important. So, Carlos, what did you say again?
I said there's just more bytes in the frame.
More
There's
bytes? In what way? Like, in what way does it put more bytes in the frame? Actually, when they say ISL, I want to give someone another opportunity before I go ahead and quickly answer it. And in what way, Carlos? You're right, but in what way does it have one? Powell already mentioned the answer, actually. So Powell said one insert 802 tag, while the other encapsulate frames. So can anyone explain what Powell is saying?
so like I said, ISL encapsulate frames, so each time it's like adding more layer of information on the
Good one.
outside.
So you have a frame that come to a port that is configured for ISL trunking. So the port got source MAC address, destination MAC address, and all that stuff. So it's got source MAC, destination MAC. So let's just put source MAC. Oh, sorry, destination MAC first, actually. So let's delete this one and let's go. It's got destination MAC and then it's got source MAC, destination MAC here, and then it's got source MAC here, and then it's got the payload here, which is the data that you're sending. So when a port that is configured for high SL trunking, when it receives this, what it's going to do is going to go, yeah, I'm just going to add a new, like you said, Carlos, a new 26-byte header to it. And the 26-byte header has lots of different fields. Lots of different fields. It has a field for BPDU. So it's going to add this 26-byte header and it's going to add this 4-byte trailer. So it's actually creating a new header and creating a new trailer and just packaging it. So it won't touch the original frame. It leaves the original frame exactly the way it is. It just adds a layer of information, huge layer of information. Because out of this 26 bytes that it's adding to the header, 26 bytes header, how many bytes do you think it uses for VLAN ID? How many bytes do you think?
4.
4. Is it 4 or 2?
One of them.
VLAN ID
Okay,
is
2.
like 4096, so it should be like 1010
Which one are we talking about?
to
We're
rough.
talking about this one. Talking about ISL. In terms of VLAN ID, how many bytes does it use for the? It's not something that you need now, but let's just bring it up and just see. Yeah. How many bytes does it use for VLAN the VLAN tagging?
How many bits does it need
It
to
uses just 2
do?
bytes.
Really?
So out of these 26 bytes, only 2 bytes are actually used for the for the VLAN ID. So it's got like all these other 22 bytes that are doing all this other stuff. And the reason for that is that when Cisco first created ISL, they had a lot of vision, you know. They were like, we can use it for this, we can use it for BPDU, we can use it for, so they have like all this other stuff that they're like, yeah, we can use it for all this stuff. But the whole thing itself is just 2 bytes that eventually became necessary. So you got lots of stuff in the beginning, lots of stuff at the end, 4 bytes at the end. So that's the way ISL functions. Whereas 802.1q, the way it functions is this. So let's get our frame again. So we have our frame. So this one gets to a port that is configured for 802.1q trunking. What 802.1q, what it's gonna do is it's gonna tag it. So this one is actually the one that is doing tagging. This other one is doing encapsulation. It's putting a new header and a new trailer. The advantage to that is that it doesn't need to calculate. So at the end of this frame is the error detection, frame check sequence or CRC, whatever you want to call it, cyclic redundancy check. So it does the error detection calculation at the end. You don't need to touch it. I mean, because it leaves the original frame the way it is, you don't need to change that. But the way 802.1q does is that it's going to modify this original frame and it's going to add a little 4-byte information just right after the source MAC address field. It's going to add a little 4-byte information here. And then the result of that is because the original frame has changed, it has to recalculate the frame check sequence or the CRC, whatever you want to call it. So it has to recalculate that because now it's modified the original frame. So inside this 4-byte tag that 802.1q has added, there are 2 main fields. Number 1 field is the one for VLAN ID. Let's just call it VLAN ID, which is only 2 bytes. So it's 2 bytes, so that's what it uses to identify the VLAN, whether it's VLAN 1 or VLAN 4 or VLAN 20 or VLAN 1000. It's only 2 bytes. Then it's got another field. I don't want to know which other field is important in this 4 bytes that has been inserted. There's another field that is important, and I think it's 3 bits or something like that. The priority, which is used for QoS. So it's got just right in the 4-byte that is inserted. So that's why you can use VLAN for your QoS. Because in the tag that is being inserted by 802.1q, there's a little field there that you can use for priority, where you can mark class of service. And you can say, this class of service is higher than the other one. And basically, if you go on Wikipedia, whatever, and just search for class of service, PRI, stuff, and you get lots of information on that little field, so where you can use for a lot of the priority for QoS priority. So yeah. So okay, actually let's see this one. I think this one's got see showing anything interesting. Yeah, okay, yeah, look at this. But this one is not clear. It's got Ethernet frame, so you can see VLAN ID here, and then right in front it's got priority here. So that's what it uses. So is that clear in terms of the way ISL and 802.1q function? Is that clear? Or is there any question regarding that? Any questions regarding ISL and 802.1q?
When you're using Cisco, what is the recommended what's the recommended protocol to use? Is it 102-Q or is it ISL?
Actually, what does anyone want to answer that? What do you think, Imran or Mark? Mark, what do you think? Which one do you think is recommended?
We use most of the time. I also always say that Q1 dot one Q.
Yeah.
I never saw ISL.
Yeah. Actually, yeah, dot one Q. Yeah. So yeah, you're right. So actually, yeah, exactly. Yeah. So let's
Um,
see. Yeah, carry on, Carlos.
I was just reading over, I guess, a bits, but the VLAN identifiers not till the end, like Powell says.
Hmm?
The first 16 bits, the TPID tag protocol identifier.
Yeah.
Like there's certain protocols that you can identify for quality service. I think maybe you're maybe mixing that up or something.
And which one is that?
I'll link it.
Yeah. So yeah. So yeah, to
You
answer the question that Remy asked earlier. So I'll click on that one now. So the recommended one is 802.1q, and the reason is actually on newer Cisco switches, some of them you won't even have the option to configure ISL.
Okay.
Yeah, because it's kind of like it's not as effective. You know, you're adding 26 byte header and 2 byte trailer, and then the other thing is you have to always make sure that you configure ISL. Yeah, ISL statically on all the ports, because otherwise, if a frame arrives on a port and the frame, normal frame size is 1,500 bytes, right? But now you've added 26 byte header and a 4 byte trailer, and if a switch port receives that, it's going to go, I have absolutely no idea what size is this one. I have absolutely no idea what is in all this header. It's just going to drop it. So ISL is kind of like fading away. It's mainly around, from my own understanding, it's mainly around for backward compatibility, whereas 802.1q does it more effectively. Yeah, so let's try to answer Carlos' question also. So Carlos posted something here, yeah.
Yeah, so if you look, it says the TPID, which is saying it's like set to 0x8100
Mm-hmm.
in order to state that it is a .1q tag frame.
Yeah,
Those first 16 bits, those first 2 bytes.
yeah. As
As
in,
in, that's always set the same, right? So that's always set to .1q. Uh,
which one is that? I'm not getting the question.
so right there,
Yeah,
TPID. And
TPID,
if you
yeah,
look under the description, it says it's a 16-bit field, the 2 bytes.
yeah,
It's always set to the value of
yep.
0x8100, so that the switch knows that it is, in fact, a .1q.
1q, yeah,
That's how it identifies that it's actually
yeah.
.1q.
Dot 1q, yeah, yeah. So that's
And in
how
the
it
example
identifies it.
before, I was just kind of confused because you had the VID before the priority. So, yeah.
No. Oh, sorry. Don't mind my diagram. My diagram is not accurate. Sorry about that. My diagram is not accurate according to the textbook. I'm just drawing to illustrate. So yeah. So it's not that way. So it's this way. So TPID to identify that it's an 802.1q frame, then followed by 3-bit priority field, then followed by the CFI, then followed by the VLAN ID, which is actually the one that it's using to
You change it
identify
because I see
the
it's
VLAN.
supposed to snow on Tuesday.
Yeah. So is that clear now, Carlos?
Yeah.
Yeah, yeah. So don't mind my diagram. You can ignore my diagram. It's just for explaining stuff. Okay, so let's see what else for today. So today we've discussed VLANs and we've discussed trunking, and there was something else I was thinking we're going to be able to discuss. Actually, let's just start it today. We won't finish it today, but let's just start it. And that's in terms of um, if you've got let's close this and let's delete this, and that's the concept of DTP. So we won't finish it today. We just start it today, and then we'll stop for now. So in terms of DTP, so what's your understanding of DTP, Mark? I think we didn't call you a lot today. So what's your understanding of DTP? So is Mark still there? Can't hear Mark anymore. Yep. Yep. Good one. Good one. Dynamic trunking protocol. Mark, we can't hear you anymore.
I think he stepped away.
Yeah. Oh, okay. Yeah. Compatible. Yeah. Yeah. Kevin, what did you say? You were saying something.
No, I'm not good with dynamic trunking protocol.
Yeah. Cisco
So I'm
proprietary. No problems.
watching right now.
Any other thing regarding DTP and the way DTP operates?
Is it only for VLAN aware switches or?
So actually, let's mention something important. So we mentioned earlier that there are some situations where some things are wrongly named. Yeah. So there are some situations where suggested to be disabled by Cisco. Yeah, exactly. Agree, Imran. So there are some situations where some things are wrongly named, where they name, where they say, one of the good examples that I use is where you go on the Microsoft system, you have a system volume and a boot volume, where the boot volume contains the system files and the system volume contains the boot files. So, so this is kind of like that kind of situation where you have something that is wrongly named. First of all, DTP is not a trunking protocol. We already talked about the trunk the two trunking protocols earlier, ISL and 802.1q. Why they've named it dynamic trunking protocol, no idea. But it is not a trunking protocol. It's a trunking. No, sorry, it's a negotiation protocol.
Is it like a mixed mode where it can be trunking at some time?
Yeah, so it could be trunking, but it could also lead to being an access port. But I'm not sure why they've named it. So it's not a trunking protocol. Two trunking protocols that we have, not a trunking protocol. Two trunking.
So I know from working on some switches, we have some Dell equipment and they use a general, but it's basically the same thing where it can be an access or a trunk
Yeah,
port.
yeah,
I have an idea.
yeah. Carry on, Remy. Yeah, you're right, Carlos. So
If if you attach let's say you connect a computer to a subnet that's currently applied to a different VLAN, then you don't need to configure that port for that computer. You just dynamically apply all the necessary um, program that you need to do for that computer to be on that VLAN.
so if I get your question properly, what you're asking is, you put a computer on a VLAN.
Mm-hmm.
That is probably good to make it static. Is that the question you're asking?
Yeah, I think when we were talking about VTP is kind of static
So we're not talking about VTP
VLAN
yet.
protocol.
We're not
Yeah.
talking about VTP yet. We're talking about DTP.
Yeah, but GTP does that automatically. Just like you have the DHCP does all the things that you need to assign IP.
Mm-hmm.
When bootp will not do that,
Mm-hmm.
but GTP kind of does all the things that necessary to put a computer to dynamically assign the tagging system and put it on the right subnet and everything. It's confusing, but when I was studying Network Plus, that's how I got away from it.
I mean, DTP, this is what DTP does, and to put it simply, you have your switch, and on your switch you have your switch ports on your
Hmm.
switch. So you have your switch port here, you have your switch port here, you have your switch port here. So all these are on your switch. So what this DTP does is this. If you take a computer, so let's say this PC, and you connect this PC to this port, DTP can automatically detect that, oh, this device that you've plugged in is a computer. And DTP will say, I will configure this switch port as an access port. Then you go to this other port and you plug in a switch. And normally between your switches, you want a trunk port, right? Because you want it to carry all the VLAN traffic on a single connection. So what DTP can do, no problem, Zima. What DTP can do is that it will automatically configure this port and say, hey, no problems, man. No problem. See you later, man. It's going to automatically say, okay, you've plugged in a switch. I will configure this port as a trunk port. So that's what DTP does. So DTP is just a way to automatically set ports to be access or trunk ports. So rather than you going manually and going switch port mode access or going switch port mode trunk, DTP can automatically detect, oh, you've plugged in a switch, therefore I will make you a trunk port. Oh, or you've plugged in a computer, therefore I will make you an access port. So that's what DTP does. But like Imran mentioned, it is actually discouraged by Cisco, and we'll mention this next week. We'll continue from here next week. So it's actually something that Cisco discourages you to do. Because, for example, we mentioned earlier that if you have a virtual server here, if you have an ESX server or an Hyper-V server here, what you want is a trunk in between these two. Unfortunately, DTP won't be able to do that because the switch inside your ESX host doesn't understand DTP. So you probably configure this port as an access port, whereas it's supposed to be a trunk. So DTP is just a way to automatically configure switch port as access or trunk. But it's not a good idea, but for the exam, we just learn it for the exam. But it's not a good idea for the real world. It's not a good one. Yeah, okay, yeah. So any questions about the things that we discussed today about trunking and VLAN?
So DTP is just a feature that has a subset of commands available.
Yeah. So DTP is like Power mentioned, it's Cisco proprietary, and all it does actually, if you go, let me go here.
But it gives you different modes like dynamic.
Yeah. So that one we'll talk about that one, because you've got a switch port can be in different mode. It can be an access, it can be a trunk, it can be something called dynamic desirable, or it can be something called dynamic auto. And what we'll discuss next week is that dynamic desirable. Yeah, exactly. I believe so too, Powell. I think it will fade out because it's not really popular and it's not really, yeah. So dynamic desirable means sends DTP packets. So what will happen is when you plug in this PC, let's say this port automatically, so every switch port on a Cisco switch is set to dynamic desirable by default. Every single one of them, they're set to dynamic desirable by default. So let's say you plug in something here. This port is not accessed by default, it's dynamic desirable. So let's just call it dynamic desirable. Yeah. So this is a dynamic desirable port. So what it's going to do is it's going to send packets to this guy at this other end. And the packets basically contain information saying, I'm okay to be a trunk. I'm okay to be a trunk. I'm okay to be a trunk. And it's listening that, is this guy going to send anything back to me? Now, this guy won't reply because it's not a switch. He's not going to reply and say, I desire to be a trunk. He's just going to be like, nothing. So this one will be an access port. But you've plugged in a switch here. It's going to be, I desire to be a trunk. I desire to be a trunk. This one too will reply, yeah, I desire to be a trunk too. Therefore, they will negotiate a trunk. You get the point? So that's what it's doing. So it's basically, if you go online and search for DTP, just DTP packet. I saw one on Cloud Shark recently. So just so DTP, yeah, DTP capture. And then if you go to Cloud Shark, you can see Cloud Shark is a really good tool for where you can actually see packet captures on the internet without having to download and install Wireshark. So you can see example DTP packets. So you can see dynamic trunk protocol. And it's basically just sending this packet to the other side and saying, hey, I desire to be a trunk. And if the other side responds, it's going to say, yeah, we can be a trunk. But we'll go into details of how it actually does that next week. So again, remember, DTP is not like a trunking protocol like ISL or 802.1q. The name is just poorly named. All DTP does, it automatically assigns your switch port as access port or trunk port. So that's all it does. It's not tagging anything. It's not doing what ISL and 802.1q are doing.
Yeah, it's not a protocol for trunking at all.
Yeah. So yeah, it's kind of
It's
like
just a
those kind.
method to switch the port between
Yeah.
being trunk or not.
Yeah. I mean, we do get stuff like that in IT. Like I was doing a lab yesterday on a Microsoft system, and it was on radius configuration, and I got to this screen and it says, configure new radius client. Yeah, power is right. So it says configure new radius client, and then I went to the Microsoft documentation, and then it says actually this is not you're not actually configuring a new radius client. You're configuring the server that is going to be working with. I'm like, but it's got on the menu. It says new radius client, but like, no, actually, it's not new radius client that you're
There's
configuring.
like some default radius already set up. You're just
Yeah,
changing the base configuration.
yeah. So yeah, we get some things like that in IT that are not named properly sometimes. So so yeah, this is one of those things. So dynamic trunking protocol. You think, wow, this thing is trunking and all kinds of stuff. Well, it's not it's not trunking any it's not trunking anything. It's just automatically assigning your port as access or trunk port. So Powell says, I believe that DTP will fade out soon. 2950 dynamic desirable, 2960 dynamic auto. So on next generation, it will be switch port, no negotiate by default. Ah, okay. Nice one, Power. I didn't know that. Is that information from Cisco regarding that? That it will be no negotiate by default. Yeah, but again, it's not something that's popular because you don't want something to be automatically assigning your switch port as strong or access. Because what could happen is think about a security situation is you have your port here by default dynamic desirable. So yeah, you have your port here by default dynamic desirable. Now think of a situation where somebody comes to your network with a switch. They plug it into this port. So by default, this guy will be sending DTP packets, while this guy will be sending DTP packets. So they negotiate a trunk. And by default, a trunk carries all VLANs. So that means this guy can basically put Wireshark on on this port and capture all your traffic for every VLAN. And this guy can basically go, well, let me configure this port here on his own new switch. Let me configure this one for VLAN 5, this one for VLAN 6, this one for the secret VLAN. You get the point? So it's like you don't want it to be doing anything automatically. Switches are one of the things that doesn't change every day on your network. It's not every day that you install a new switch. So you want it to be as static as possible. You want to know exactly where your trunk links are. You want to know exactly where your switches are. So you don't want it to be something that, somebody can just plug in a switch and all of a sudden there's a new trunk port transferring all VLANs and all that stuff. Mark, do you have any questions?
Hey, so no, I'm just listening.
Yeah. You have any questions about trunking and VTP? Yep.
I must have missed the part in the book where it talked about DTP because
Well, no, wait.
I don't know. I'm looking for it now, but it's like 2 sentences. And that's it.
No, we're not. No, we're not talking about DTP in details now. We're
Okay.
just introducing it now. We'll actually talk about DTP next week. We'll start from DTP next week.
All right.
But okay, so let me ask this question, Mark. So you understand trunking and VLANs properly, right?
Sure.
Yep. So so to ask you a question, so let's say someone we've got two switches. Someone is connected to a VLAN on another switch. So let's delete all these guys. Control Z. let's delete all these guys. So in this situation, you have two switches here, and they have a connection in between them. You have this guy on VLAN 40, this guy on VLAN 40. But this guy on VLAN 40 here cannot ping this guy here. What are the things that you look for?
Wait,
What are the
say
things
it
that
again.
you check?
Who can't ping who? What?
So this guy, so this is a computer, so this is a
Uh,
PC, and this is a PC. PC, and this one is a PC. And this is a switch with a trunk link in between them. Yeah. So, but you can't ping this other PC from PC here. So what are the things that you check for? What are the things that you look for that could be the cause of that?
the IP address setting on the PCs.
Yep, okay, good one. IP address setting on the PC. Anything else? Anything else relating to what we discussed today? Anything else that you look for in terms of what could be the problem?
No, I'm drawing a blank. I could probably figure it out in like packet tracer, but no.
Yeah.
Um,
Does Carlos and Remy you want to help, and Kerry you want to help? So want to help Mark?
You can check the settings on the trunk port to see if VLAN 40 is allowed.
Good one, very good one. So you can check the settings on the. So Mark, did you get that?
yeah.
So this port you can check the settings on the trunk port and see if VLAN 40 is allowed. What if VLAN 40 is allowed? What else could you check?
I guess that if it's also tagging it, right?
Yeah, I mean you're close. The other thing I'll say is, let's say for some reason the tagging protocol are configured differently. So maybe the guy here has configured it for ISL and the guy here has configured this one for 802.1q. And how do you check that? How do you check which protocol is in use on your switches? How do you check?
Show VTP or
VTP?
Your
no?
int
Oh,
protocol.
Protocol? Okay, maybe this packet tracer. So I think you're right, Kelly. Mango says show int trunk. Yep, so I think this one is accurate. Show int trunk is one way to check. So if you have you want to check which ones are trunk links, let me just bring this one up and connect. Connect a. Now there's a packet tracer bug that probably won't make this work. But then
Yeah.
show int fast01 switch
Yes.
port. Yep, so you can see administrative trunking encapsulation .1q. So this command is actually a really good command when we start talking about DTP next week. So show
So
interface switch port at the end.
is that another one of those things, administrative trunking encapsulation?
Which
That's
one?
one of those miscommunication things, since that one queue doesn't do encapsulation.
Administrative trunking. Yeah, exactly, exactly. Yeah.
So that's a good interview question.
No, actually, if an interviewer asks me that, I mean, I think that's really mean. If you're gonna be asking me those kind of stuff, I think that's mean. Whether it's encapsulation or this one, I think that's mean. Okay. Yeah, exactly. Yeah. So in switch port, and that can show you. So this is a really good command. Okay, guys. So we'll continue from here next week. Except anyone wants to do some labs. So if you want to do some labs, uh,